All right, here is the substitution homework. The first thing you might notice is that this is a long homework assignment, 15 problems. And I guess the first comment there is sorry, but the second comment is that wasn't like some mistake and I just forgot to make it a reasonable length. I purposefully made this homework really, really long because this is a skill that just kind of demands a ton of repetition. And not only does it demand a lot of repetition, it's a really important skill. It's a skill that'll benefit you later on in this class and also in future calculus classes. So I really wanted to hit it hard. Hopefully 15 will be about the right amount where when you're done with them, you feel a little bit worn out, brain dead. It might take you a couple different days to work on this, but it won't be like, look, I got the point and I didn't learn anything from the last 3. It was just wasting my time. Without further ado, this first problem, it's meant to be more of a beginner level problem in that they tell you the substitution that you should do. They say, let u equal x to the 4th plus or minus 6. And you might have guessed that right off the bat. You might have been like, yeah, because that'll make this really nice. It'll just be u to the 19th. And my du will kind of take care of this x cubed. And it'll be a really easy thing to evaluate. And totally right. That's what you end up doing on this problem. One little comment here is they also give you a hint. They're like, when you figure out your answer, it's going to be in terms of u's. Make sure you don't leave u's in your final answer. Make sure you substitute back. What they're saying is change your u's back to x to the 4th minus 6 before you type your answer in here. Second question, I don't know if it's any more difficult than the first question, but it's not set up to be a beginner question. That is, it doesn't tell you what you should make your u substitution. I think you'll be able to figure this out. This isn't a really tricky case. Try to recognize something in here so that its derivative is also close to in here up to a constant, and you'll be able to evaluate this guy. This third one, again, it doesn't tell you what to do the u substitution. It's hard for me to not just tell you. I guess here when you're doing your u substitution, you don't want your du to be underneath the radical here. So maybe your u will be under the radical somewhere. And whether it should be x to the 6th or 1 plus x to the 6th, think about whether you'd rather end up with the square root of 1 plus u or just the square root of u when you do all your substitution. This fourth problem is a little bit interesting. The comment here is, and this might not seem like a hint that's relevant, but I think when you're working on this problem, note that 2 times, and then in parentheses x plus 4, is 2x plus 8. And you're like, yeah, I know that. Right, but if you have that fact handy, that might help you figure out the u's and the du's and how they all fit really well in this problem. It almost feels like a contrived problem. You won't have to do a whole bunch of algebra. You won't have to split this up into 2 different fractions, for example. The du will work out really nicely. Question 5, no real comments here. They change your variable of integration, but maybe you can do a fairly easy u substitution to allow you to use the fact that you know the antiderivative of 1 over u. This one, you didn't really see anyone like this, so maybe I just give you a hint. You don't want your u to be sine to the 5th power x, or sine of x to the 5th, because then you'd have to use the chain rule, and your du would be 5 times the sine to the 4th power of x times the cosine of x. It would blow up. It would be a mess. So maybe instead just let your u be equal to sine of x, and I think things will work out nicely for you. This one, I think you'll be able to figure out what u should be equal to, and then the du will fit pretty nicely. I don't know, you see this natural log in here, and you see this 1 over x in here, so just be careful. Which one of those is the derivative of the other one? Hopefully you can get that guy to work out for you. This guy looks horrible. It might end up being one of the easier ones that you have. It's easier for you to recognize the derivative of arcsine of x when arcsine of x is also already in the problem. It makes it more obvious that, oh, I also have this 1 divided by the square root of 1 minus x squared floating around. So maybe that'll help you do your substitutions. For this one, instead of an indefinite integral, it's a definite integral. I think I only gave you a couple of these just because they're a little bit tedious and I didn't want to waste your time. I think the u substitution you do here will be fairly straightforward, but you'll have to be careful about your bounds of integration. Remember how that works when you're doing a u substitution on a definite integral. 10 is the other one with a definite integral in here. It's a little bit harder in terms of the u substitution that you do than this one is up here, but the u sub shouldn't be too hard, not as hard as some of the other things that you've done, and be careful with your bounds of integration. Nope, I lied. There's 3 definite integral questions. Here's the third of the 3. I do have a hint for you here, and the hint is that 9 times x squared is the exact same as, in parentheses, 3x squared. And I think if you rewrite this as 3x squared as opposed to 9x squared, hopefully the pause there helps you tell where the parentheses end. It'll make it easier to do your u substitution. Think inverse trig if you need to. 12 is not too bad. I think you can figure it out with I think you can just kind of play with your different options and figure out what u would have to be to make your du appear. It won't be any crazy algebra or anything. But 13 and 14 are both pretty tricky. I think they'd both be unfair homework questions had I not made that last video that gave you like the trick examples. I think you'll find an example in that video that's similar to 13, and you'll find another one that's similar to 14. So reference that video for the two of these guys. And then finally 15, you don't have to do it. And this might be one where you're like, look, I'm good. I'm so tired after doing all these problems you gave me. I don't even want your extra credit. But if you do want to try to attempt 15, the trick for it is to algebraically manipulate this before you do your u substitution. So what I'm saying is when you have a sum of terms up in the numerator, you can rewrite this as 4x over this x squared plus 1 plus 1 over this x squared plus 1. But if you don't split them up into two fractions and you try to mess with this, you can get stuck and it can be really frustrating. So I wanted to give you that advice. Hope that helps a little bit. Good luck with this homework. Again, sorry about the length. I hope it's not too bad for you.